Okay, so we want to look at how to graph a quadratic function in this very specific form here by using symmetric points. There are other ways to graph them as well. Okay, so first of all, you should recall that a quadratic function has an x squared somewhere. So the squared is the key to this, and so you see that up here in this form. The x part is squared. So in general, a quadratic function can always be written in this form, which we'll look at in a different video. But if it's in this form, it's very easy to graph, and we'll see how to do that. So what we're going to do is we're going to focus our graphing all around this number where x is positive 4, because what we're going to do is we're going to focus on making this part of the function that is squared, we're going to focus on making it 0 somehow. So what we're going to look at is when x is 4, we need to figure out what y is, and y is the function value, don't forget. So when x is 4, y would be negative 2 times, well, 4 minus 4 is 0, squared is 0 plus 3. So y would be 0 plus 3, which is 3. So we get this ordered pair where x is 4, 1, 2, 3, 4, and y is 3. That would be up here. This is what we call the vertex. The vertex, you'll see in a minute, is where the function doesn't have a mirror image. So let's discuss that for just a minute. A quadratic function graph will always be a parabola, and it will either open downward like this, or it will open upward like this. Okay? The vertex is always this peak or valley of the parabola. Every other point on a parabola has a point that is symmetric to it, right? It has a mirror image on the other side. So you can see that here. So the vertex is the only point on the parabola that does not have a mirror image because it's at the peak or valley. So this point here will be our vertex because that's where this value is 0. Okay, so that's our vertex. I'll label it with a V. Now we need to find two symmetric points. So what I'm going to do here is just draw a green dashed line that's vertical. This is what we call the axis of symmetry. So let me label that, because all of your points will be symmetric about this green line now. So what I want to do is now I want to choose a point to the right and to the left of this x value of 4. So let's choose an x value of 5. Okay. Now since 5 is 1 unit to the right of the number 4, its symmetric point will be 1 unit to the left of 4. So I also want to choose the x value of 3. Okay. So let's see what happens if we choose those two values. If x is 5, y would be negative 2 times, well, 5 minus 4 is 1, so you end up with 1 squared plus 3. Negative 2 times 1 squared is negative 2, plus 3 is 1. Okay? So let's see what happens if I plug in 3. You get y equals negative 2 times 3 minus 4 is negative 1 squared plus 3. Now the interesting thing about this is, here I got a positive 1 squared, here I got a negative 1 squared. The thing is, if I square those, I get the exact same value. So this ends up being positive 1 as well. These are symmetric points because they give you the same y value. And you can see it if you plot it. If x is 5, y is 1, so that point is here. If x is 3, y is 1 also. So there are mirror images of each other across the axis of symmetry. Okay? By the way, this axis of symmetry is a vertical line, and the vertical line in this case can be described by the equation x equals 4, right? Vertical lines are always x equals a number, and in this case x equals 4. Let's find another set of symmetric points. So I've chosen 1 to the right and left of my vertex. Let's now go 2 to the right and 2 to the left of my vertex. So I want 6 and 2. So they're symmetric, so they're going to give me the same y values. I get negative 2 times 6 minus 4 is 2, so 2 squared plus 3. 2 squared is 4 times negative 2 is negative 8 plus 3 is negative 5. If you plug in the 2, you're going to get a negative 2 inside the parentheses here, and you'll still get a positive 4 when you square it. So these 2 points look like this, and you can see they're both symmetric again, and now you've got a good idea of what this parabola looks like. So that's how to graph a parabola. In general, this parabola opens downward because this number is negative. The a value is negative. If it's positive, it opens upward. You can find the vertex and then look at symmetric points.